Hi all, thanks for joining the Conference 42. My name is Venkata Kumar Majeti, working as a product owner at Salesforce. I did my masters from National Institute of Technology, Warangal. Today I am going to present a topic on AI-driven incident resilience, scaling subscription systems in the $400 billion economy without losing uptime. In, as for today's agenda, we are discussing around four topics: subscription economy landscape, AI driven incident detection, architectural foundations, revenue protection strategies, implementation roadmap. So, when it comes to subscription economy landscape, let me go to it's a $400 billion opportunity which has a market size of 400 billion. The current valuation of the global subscription economy, it's growing at a faster rate of 18.2% per annum and compounded annual growth rate since 2018. The main focus is on the digital services. The percentage of growth is driven by these digital services. The shift represents a fundamental change in how business delivers value and greater revenue. The scales of the enterprise reliability is now directly tied to revenue retention. So revenue retention is important when considering along with the incident management systems. Though the cost of downtime in subscription businesses beyond immediate revenue loss. Apart from the revenue loss, there are other impacts that focus on the importance of doing the AI driven system. The average enterprise SaaS company loses 300K per hour of downtime. With this downtime, its impact of is more, and customer acquisition cost wasted when new users encounter errors, and 15 to 35% higher churn rates following significant service disruption. Brand reputation damage requiring 6 to 12 months to fully recover. So to recover a brand name, the brand, the marketing and all, it takes around a year to fully recover. So to avoid this, the reliability paradox. So we can say what factors affecting the reliability. So growth demands innovation. To get growth, you need innovation is required to excel. So subscription business must continuously buy new features to remain competitive and meet evolving customer expectations. Without the new features, you can't grow faster and compete with other competitors. So innovation is a must to grow, and innovation introduces risk. When you are innovating something, the risk will also add with the new innovations. So each deployment, integration, and feature adoption, its potential failure points in increasing complex systems. This is based on the complex system, the new feature, the new integrations will increase the failure points. And comes to reliability requires stability. To get it more reliable, the stability is the key. Maintaining near feature uptime, perfect uptime traditionally meant slowing release cycles and limited changes. So we try to reliability to increase the reliability and stability. We need a perfect uptime and slowing release cycles and limited changes. So there is a tension between the innovation and stability, created an impossible choice for engineering leaders. Now AI-driven incident resilience emerged as a solution that enables both rapid evolution and robust reliability. So this AI-driven solution will help in a robust, so it gives a robust reliability. That's what we are focusing on with the AI reliability. And comes to the second topic, the AI-driven incident detection, the new paradigm. So we going to the AI as a predictive models. So from reactive to predictive. As of now, the traditional incident management relies on monitoring predefined threshold and metrics like log time, call time, durations. So detecting problems only after they are impacted users. we are getting the metrics or KPIs after the users are getting impacted. That AI transforms this approach by learning normal behavior patterns. With AI, we can understand the behavior of millions of system transactions by analyzing the behavior of the patterns, detecting subtle anomalies that human operators would miss. AI can find those subtle anomalies where a human can't find it, and predicting potential failures. AI will predict the failures before it is cascaded into major incidents, continuously improving through feedback loops and outcome analysis. Feedback loops like the AI trained systems with feedback responses, and it will give a better outcome. Let me go to the next topic: architectural foundations of resilient subscription platforms. So it main focuses on distributed processing. This architecture lays the foundation for distributed processing. So horizontally scalable microservices with intelligent load balancing and regional failure capability. Intelligent load balancing route the traffic to the different microservices in highly scalable environments. And data streaming, real-time event processing with buffering and replay capabilities to prevent data loss during incidents or outages. So data streaming with event processing and a sufficient buffer, we won't lose the downtime and we'll get the required data even during the loss of during incidents. And multi-region resilience. So these one active deployment models with automatic traffic shifting during regional incidents. Like one region has an incident, it will route to the traffic to another region. So it will provide better region resilience and stateful recovery. Stateful recovery is transaction and session management with automated recovery from partial failures. So the stateful recovery is the failures, some of the failures which can be recovered without any manual intervention or human intelligence. This AI can recover partially. So these architectural components, these four components work together to ensure that even during incident response, the customer experience remains minimally impacted with near continuous uptime. Continuous uptime is minimizing the downtime. And intelligent storage and retrieval systems. These storage systems will minimize latency even during incidents. Latency is like the time the response is taken. It will minimize the latency. The intelligent storage systems and retrieval systems will minimize the latency during incident. So the advanced storage and retrieval systems are critical to maintain performance during incidents. So these systems are critical to maintain the performance when any incident happen. So predictive caching. So it will predict how much what to be cached. That prepositions frequently accessed data. So the frequently accessed data will be cached based on the usage patterns. And intelligent data tiering that balances performance needs with storage cost. The data tiering is which level of data where to store is balancing the performance when it getting accessed, and it will reduce the storage cost. The faster response requires more storage costs like RAM hardware. So the intelligent data tiering is like that. And RED replicas that scale horizontally to handle traffic spikes. So the RED replicas is quite commonly used data by multiple millions of users that can scale horizontally to handle traffic spikes which distributed to multiple systems. The graceful degradation that prioritizes core functionality during resource constraints. So this one is the priority goes to the core functionality, and that during resource constraints it will benefit in improving the latency. And this is a metrics the leading platforms achieve 99.99% availability for read operations even during significant backend incidents, ensuring users can still access their content. So the beyond detection, they not only detect the problems, incident management, but building revenue protection. It will help in building the revenue protection. So AI extends beyond incident management to actively protect revenue streams without any outages, customer satisfaction, churn protection. So let me go to the next topic on this. Adaptive churn models, retention during incidents. So advanced subscription businesses are implementing AI-driven retention systems that specifically target risk customers during and after incident windows. Risk customers are like which are sensitive to the customer experience. And these are evaluated using impact scoring. It will real-time assessment of how incident affects specific user segment based on their interaction patterns. Proactive engagement. So how it is automatically personalized to affected users with appropriate context and compensation. Recovery monitoring. Tracking post-incident usage patterns to identify users showing disengagement signals. So these three help in retention the customers during incidents. Like scoring how at what segments of data users are getting impacted and how we engage the users, how we can monitor them back after incident and see how the user behavior. So the disengagement signals helps in retention during incidents, how we can retain the customer using these models that help to improve the user experience or user customer satisfaction after incidents. AI-enabled personalization frameworks. So AI is using these frameworks to better improve the incident management and revenue model, user behavior analysis. So in this, it's continuously monitor of interaction patterns, content preferences, and usage frequency. How frequently they use the same data, what is the preference of using the data. So this user behavior analysis is the key part in the framework. And dynamic segmentation. So this is like on a real-time basis, classification based on behavior. So this is dynamically classifying the behavior of the user, not just static demographic attributes like region, how the user behavior is. It's not like static behavior. It's dynamically based on the how user is behaving. And personalized experience. This is like tailored interfaces, content recommendations. The AI can identify what is good recommendation based on the user behavior and feature highlights. This is the key in the framework. And engagement measurement. So we generally take the metrics, comprehensive metrics, capturing depth and quality of interaction. How, suppose they can, how long the video is and how much time they watch it. This is an easy example of engagement measurement. These systems maintain engagement even during incident recovery periods by routing users to unaffected features and contents, minimizing the perceived impact on their experience. So during instant recovery, even the AI-enabled system will track and provide the unaffected features and content. Companies implementing advanced personalization see 22 to 28 higher customer lifetime value and significantly improved resilience to service disruptions. So the companies who are implementing this model frameworks has better advanced personalization, see 22 to 28% higher lifetime, customer lifetime. So those who are taking a 1 year subscription, they are continuing to 1 year subscription, not terminating at 8 months. These frameworks help to retain their customer lifetime and significantly improved their service even during descriptions. And dynamic pricing algorithms help in improving the revenue model during the incident. So this is mainly focusing on balancing value and revenue. So the pricing systems help in subscription business maximize both acquisition and retention. So it considers key parts: value-based pricing that aligns cost with perceived customer benefit. So it is driven by how satisfied the customer, how the content is useful for them, how value-based pricing, what value the company is providing, that much pricing, and elasticity model that predicts conversion rates at various price points. What is the best conversion rate that can be available, that can predict, the AI model can predict. And competitive positioning that dynamically adjusts to market changes. The market changes, like the customer behavior is tuning to different experience. So this AI helps, metrics helps, these algorithms helps in trying to position the company into dynamically adjustable market changes. Risk adjustment offerings that provides appropriate discounts to at risk segments. Some segments are risk, so it will provide a better offering and it will recommend go right. These algorithms help in optimization of those risks. These systems automatically adjust during incident recovery periods. So if an incident happens, so how we the AI will balance out the value and the revenue. These four models will help in balancing out the value and revenue during incident recovery periods, the downtimes, feature unavailabilities, system failures. So providing target incentives to users who experience service disruption. So it helps to find the right segment of users and provide the right with broadly discounting for unaffected segments. And what is the journey to optimize this? How, what is aware user journey optimization? What is the user journey during this incident management process? So say the before the incident, pre-incident, standard personalized journeys based on engagement patterns and conversion optimization. This is before the incident happened. We have these engagement patterns, how the customers are engaged with the features or patterns we have. And active incident, dynamically rerouting to functional features, transparent communication, and expectation management. So during an incident, this AI model will help rerouting to functional features, how which feature is more feasible and how we can transparently communicate those features to the users and meet the user expectations. Initial recovery is like re-enabling of features with prioritized access for high value customers. So when you recover it, who is the right set of users has to access that. Then we can reprioritize to a low value customers. And stabilization, targeted re-engagement campaigns and satisfaction monitoring with compensatory offerings. So to stabilize this, understand the user behavior, understand his engagement, how user is engaging with, and by monitoring with compensatory offerings, it will offer to provide a new offers, new feature, new free features like that. And post-recovery growth, how the growth of the company or growth of the product during or after, this is mainly focusing on after incident. Accelerated feature adoption and expansion opportunities with renewed trust emphasis. Try to build the trust, try to provide the right service, try to improve the good offerings. This AI leading subscription business don't just manage incidents, they transform the entire user experience around service disruptions to maintain engagement and protect customer lifetime value. Yeah. And to implement this, what roadmap we have in place? It's like the main four categories we have: foundational data collection. It will focus on comprehensive telemetry across all the system components with unified logging and standardized event formats. The timeline, it takes around 1 to 2 months. And the next one is baseline modeling. So this during this time, it will establish normal operation patterns and identify key performance indicators, what indicators are required for specific business, and correlate with user satisfaction. To understand behavior, which patterns, which indicators are required, it will model during that baseline modeling. This will take around 2 to 3 months. And initial detection models. So this is like a deploy first generation anomaly detection with human verification feedbacks, and this loops to minimize false positive. This is AI system which will be trained with the feedbacks that's coming from human verification. So initially it starts with the AI first generation system, and later on getting trained with human verification feedbacks, and it getting trained and better for future model. It takes around 3 to 4 months. And response automation, gradually implement automated responses for well understood incident patterns with clear remediation paths. So after the initial detection models, we'll go to response automation. System is fully trained and it was gradually implemented the automated responses. As we captured the human responses in the previous months, and now we are going to automated responses. And the incident patterns with clear remediation paths, we'll analyze it. And continuing the advanced capabilities with implementation roadmap, there are two which takes one with 6 to 12 months. This mainly focus on user impact correlation, connect systems metrics directly to user experience indicators. So it will follow some of the indicators, metrics. It will correlate with the user experience, and predictive modeling for predicting from reactive to anticipatory incident management. So this is a great, with predictive modeling, it will shift how the incident management system will from reactive to predictive. And retention integration, link incident data with customer engagement systems. This will help in retention of the customers. And the second model, we have year 2 and beyond. So in this phase, it takes autonomous recovery, self-healing systems with minimal human interventions. Autonomous recovery, it will gain the knowledge by itself, which is called self-healing systems, and train by themselves without human intervention. And the next topic, it is cross-platform intelligence, which is shared learning across multiple product lines. So multiple AI models or multiple systems has common data. It will share the data to get and train the AI model. Continuous architecture evolution, system that adopt based on incident patterns. This architecture will continuously improve and improve the adaptability based on incident patterns. So incident patterns, the first quarter, what type of incidents and what geography or from which geography, which product line. So these are like incident patterns. This is continuously evolve and find the new patterns, and continuously architecture will evolve. Here's the roadmap and the guidelines for resource investment. So we classify as a team structure, which is hybrid squad combining SREs, data scientists, and product engineers. The ranges It ranged from the project size to 5 to 7 members and executive with executive sponsorship. And when it comes to technology stack, the real-time data processing framework uses machine learning operations platform and automated orchestration tools with visualization capabilities. So we need a visualization to see the performance, the metrics, the output, along with the machine learning frameworks and real-time data processing with mathematical models, which we covers under technology stack. And investment returns, we can take it around on enterprise implementations, show around 3 to 5 times the return on investments within 18 months through reduced downtime and improved retention and decreased recovery costs. This is what this AI driven system is capable of giving 3 to 5x ROI. The key takeaways with this model, it's AI driven, AI transforms incident management from reactive to predictive. So the AI model is changing from reactive to predictive. We are expecting the same. Early detection and automated response dramatically reduce customer impact. We are predicting and detecting early and providing automated response, which reduce customer impact. And architectural resilience in the revenue production strategy. So how the architecture helps the intelligent systems maintain functionality, because the intelligent system know which functionality is more critical even during partial failures. It's keep on running with critical functionality, and the user behavior patterns drive the which functionality is critical. And user experience continuity require cross-functional integration. So this is like connecting technical monitoring with customer engagement systems. So it's cross-functional integration, the technical monitoring with the customer engagement systems. The customer can do some part of our operations by themselves, and they can monitor by themselves. These features in the cross-functional integration, by cross-functionally integrate the technical monitoring with the customer engagement systems like CRM and back office systems, the user experience will improve. And implementation follows a clear maturity model. So start with foundations and progressively build advanced capabilities like auto response. Start with the initial detection model and then growing up to advanced capabilities of auto response. This helps in implementing more clear maturity model. Thank you for joining this conference.